So we are going to be finding the partial sums of an infinite geometric series. You guys had a formula for a finite geometric series, and so now we're going to be looking at infinite. So the easiest thing we're going to do is let's go ahead and write out as S is 1, S is 2, S is 3, and that means that partial sum of the first, second, third, fourth, and fifth, and sixth all together. So we're going to want to look at those points. So S of 1, that's just 1/2. S of 2 is 1/2 plus 1/4, which is 3/4. S of 3 is 1/2 plus 1/4 plus 1/8, which that is 7/8. And then you can start getting into decimals. It's going to be easier. 1/2 plus 1/16. We've got more between there. Sorry, 1/2 plus 1/4 plus 1/8 plus 1/16 is equivalent to around 0.94 rounded. And then S of 5 is 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32, and it's getting rounded at about 0.97. And I made a mistake when I find the first 5 terms. So what we see is that we're going from 0.5 to 0.75 to 0.88 to 0.94 to 0.97. We are getting in closer and closer. So if we go ahead and we graph these points, you're going to want to scale your axes for sure. But if we go ahead and, if I can get this straight-ish, and let's see, sorry, my axes are going to be better off if I do this. The reason why I did this is because we're only looking at positives, so there's no point in me doing anything smaller than a negative value, like any negative value, anything smaller than 0. All right, so this is 1, 2, 3, 4, 5. I have it basically zoomed in, scaled, so that it looks a little better because we are using such small numbers. There we go, that's a little more accurate. Okay, so 1, 2, 3, 4, 5, 6. We'll call this 1. So at 3, it's at 0.5, and then we can go from there and kind of estimate down. So at S of 1, I'm at 0.5. S of 2, I'm at 3/4, so that's directly in the middle. S of 3, I'm at 7/8. And then I'm getting closer and closer to that 1. Let me fix this one. They're just really, really close to 1, so they're going to look about the same, but that is truly the point of this. If you see, as you get, your fractions are going smaller, they're getting closer and closer to 1, but they are never approaching 1. So we are seeing it as our infinite geometric series approaches 1. So we can say that we are approaching 1 as my n value increases. Whereas n goes to infinity, our y values are approaching 1. If you guys go and look at 1/64, it's going to get you even closer. So that's how this one looks like.